Hey folks, good morning, I guess, or good afternoon. My name is Dolis, and I am a solution architect at Nirmata. Nirmata is basically the creator of Kyverno, and I am flying all the way from Canada. I do have Prashant with me. Prashant, do you want to introduce yourself?
Hello, everyone. I'm Prashant from Mirantis.
Perfect. And today we are going to talk about how do you secure the multi-cluster governance clusters like edge use cases using Kyverno and K0rden.
Hello. Hello, everyone. So today, everything is data, and data is everywhere. Why? Because all of these possibilities, IoT devices are increasing. 5G is being adopted everywhere, and GPUs are becoming more closer to the edge. So we have figured out that by 2035, there will be 75% of the enterprise having data at their closer to their location. And then managing everything is quite impossible. I mean, given the operational complexity, resource constraints, security, and connectivity gaps, scalability and simplicity versus simplicity, and there is vendor locking as well. So the harsh reality is that managing everything on the edge is becoming really fragile, fragmented, and is quite costly. So how hard can it be, right? But we do have solutions to that. First solution is K0rden, and second is Kyverno, right? What is K0rden? K0rden is a product by Mirantis. It's an open source distributed container management system. It is built to deploy and run platform on mixed workloads. It uses Kubernetes as its centralized and universal control plane across the edge and on-prem. There is automation of policy to reduce toil and with self-service. And as well, there is the enablement of AI and ML around it. It's lightweight and very composable. When I say composable, meaning, it is very simple. So you have the mothership, which is a Kubernetes cluster on itself, and then you can deploy all kinds of mixed workloads around. You can deploy on OpenStack, on all the major cloud around, and the workload clusters can be mixed. So it's very composable. You can bring your own OCI and like container runtimes, Docker, Cryo, Containerd, and even the storage as well. So you have a multitude of storage which you can use. So it's not one thing. It is not a black box, but you can compose whatever you want with it. And on the application side, you have the service catalog. So you install all your application from that. You just click whatever you want as a application stack. It will be installed onto your workload cluster directly. So there is not that overhead of having many applications everywhere, so you have everything in one place. So overall, it reduces the time to market or time to value. Then there is the real pain. Although you have a stabilized infrastructure, you do have the real pain, which Dolis will explain.
Yeah. So when it comes to edge computing, and if you're trying to spin up, like, I won't say hundreds of cluster, but around 50s of cluster, the real pain always is that there would be a lot of drift in the configuration. If you want to manage all these 50 clusters, then the configuration from cluster 1 to configuration from cluster 2, it's going to be very different. You'll see a lot of drift. You'll kind of try to figure out how to have this security posture on all these clusters. How do you manage them when you have these edge use cases where you have clusters across different sites? How do you manage all of this? How do you manage the drifts? How do you manage the security? How do you manage the configurations? And how do you manage everything is automated? That's where PAC help. PAC is an ecosystem that is developing, just like infrastructure as a code. It is policy as a code. What does it mean is, it means very simple. You just define single rule, and enable it across your application development. So it can be in your CI/CD pipeline, in your cluster, in your cloud. You don't have to write policies again and again for different sections. You just define policies one, and you just enable it across your environment. All the benefits that IAC provides us today. I remember 5 years back, IAC was a new concept. I gave a talk about crossplane, and I was trying to figure out, Terraform was huge at that time. And now we are seeing the industry is kind of adopting to IAC. All the good advantages that you see in IAC, like you can manage the resource, you can roll it back, you can have everything codify your infrastructure. All those good things also applies to PAC. You can have the policies maintained in a single repo, you can version control them, you can roll them back. You'll have everything pretty much neatly defined, just like in IAC Factor, and that will help you to automate your security by using this ecosystem. This is an ecosystem that is developing. Now, perfect. Yeah, I'm going to take this. Thank you. Perfect. So when we talk about PAC, it's policy as a code, which means it has policies. What are policies, and why do we need them? Now, I would say in our day-to-day life, we do have a lot of policies. Few we do not, they're just default. We are not aware about it. And few come on a paper, come on a contract, come on your employer contract, whatever it is, but we do have policies all over us. What does policy mean is policy tells you what you can do and what you're not supposed to do. That's what policies are. I do have a policy at my home that, you don't bring your shoes on the couch. That's a policy, right? You cannot do that. So that's just what policy does. It's not very complicated. Now, why do we need policy is, if you look at Kubernetes cluster, right? And if you look at, we do know Kubernetes is a little complex, comprehensive, and it becomes really difficult when you're scaling it, especially when you're scaling like 50 clusters. Now the complexity increases because the same application, the same YAML that you're deploying, it gets touched by different team. Operation team kind of checks the YAML or checks the application because they want to schedule it on a particular node. Developer do care about the images and certain aspect like secrets, config map. Platform team cares about, they want to provide self-service to the developers. Security team cares about the security aspects of it. So if you look at it, this YAML is being introspected by different team. And even a single misconfiguration, it can be like image coming from a public repo, or it can be pod running as root, can create a big vector for your cluster. Even if your pod is running as a root, it can bring your entire cluster down. Now, all of that is there. And then think about platform teams want to provide self-service to the developer. So if I'm a platform engineer, I do own the cluster, but I also want to provide self-service to the developer, but I do own the cluster. That means anything the developer will deploy, it's on me because I own the cluster. So how does that equation work? How will that dynamic work? I think the solution to that is deploying policies. By deploying policies, I tell the team what they can do and what they cannot do. I give them a playground, but with the guardrails. So they can play, they have their entire self-service environment, but there are a few rules that I'm adding to that so that I can manage that cluster and I can provide better ownership of that cluster. So that is entirely why you need policies, what are policies, and what is PAC as an ecosystem. Now, Kyverno is a policy as a code engine. It runs in your Kubernetes cluster, but not only just Kubernetes cluster, but you can also use it to scan your JSON, like Terraform, Docker files, anything JSON. I cannot remember, but anything JSON. Docker files, I already said Docker files, I think. Anything JSON that you can scan using Kyverno as well. So it's not just for Kubernetes. Why you want to do Kyverno and not any other policy engine out in the OSS community is, first thing which I love is it's simple YAML. You don't have to learn a new language. When you think about policies and security, it kind of makes you scary because security is a little difficult. You have to learn something new. You have to understand the terminology. That is not something you have to do with Kyverno. The learning curve is really low. If you know about Kubernetes, if you know a little bit of YAML, you'll be able to write a policy, get started. It does provide different other tools as well. So Kyverno itself has created like an ecosystem, which we fit in PAC. That means it has a tool for reporting. It has tools for exception management. It has tools for testing your policies, etc. As I said, it was initially built for Kubernetes because as it was contributed to CNCF 4 years back, but now it can do much more than that. So you can have one policy defined in your Terraform, in your shift left, in your pipelines, in your cluster, as well as in your cloud. Hey, what happened? Okay, perfect. So we do have 5 kind of different policies. And the entire motivation behind Kyverno and PAC is you don't even want to just validate something, right? Policies are good. Like, as I said, policies helps you to validate and tell you what to do, what not to do. But when you think about PAC as an ecosystem, you can actually even automate the security. Even if today you're adding a policy saying that your pod should run as a root, rather, you can have a mutate policy and patch all the pods with those security context so that your developer doesn't have to get a failed response. They don't have to go and figure it out. You can automate a bunch of these security things. And that's why we have a different policies that fits for every ecosystem. We have a validate policy, an image policy that helps you for image signing, SBOM signatures, supply chain use cases. Then we do have a mutate policy. Mutate is like patching a resource on the fly. So if you have some best practices, like application should have this naming convention, have a mutate policy. They can get mutated on the fly. You'll have the best practices, naming convention, all sorted. You have automated the security now. We do have generate policy, and we do have cleanup policies, which is last deleting policy. Generate policies can help you to generate a bunch of things, like if you need to generate resource quota, network policy, RBAC rules, everything, et cetera, on a trigger of a namespace for self-service use cases, you can use generate policy. Delete policy is basically cleanup policy. You can set up policies to clean up all the resources based on the logic. So what the intention and the inspiration was to make Kyverno fit into the PAC ecosystem and not just a validate, not validate rule. And that's why you'll see a bunch of different policies that can help you to enable those use cases. Now we're going to go back, stick to our topic, which was the edge use cases, and Prashant will walk through how Kyverno policies are helping in enabling those security postures on the cluster.
Thank you, Dolis. So how do we do that? So policy can be loaded at Bootstrap. So let's say you are creating a workload cluster. So this actually shows the service template being created. So this is actually the service template of Kyverno being loaded onto the K0rden cluster. So you just need to install the Helm chart here. And then when the Helm chart is loaded, the Kyverno is already there on the K0rden cluster. So when the Kyverno is there, which means any workload cluster that you will create, if you add Kyverno to it, it will be installed automatically. So you don't need to create, you don't need to install Kyverno on all your workload cluster. It will automatically be installed. So how do we do that? So this is the cluster definition, the workload cluster definition, and then Kyverno is already installed on K0rden, so you just need to define it here. So when you define it here, this workload cluster will actually have a Kyverno on it already. So, and then this is the policy that, it's a sample policy that you define. So this policy will be attached to the workload cluster directly. Next, please. So then when you apply this YML, you will see the workload cluster being created. And then, so you just need to apply that YML, and your cluster will be created with Kyverno loaded onto it and the policy applied to that. So then when you, let's say you deploy a pod with this policy that we created, it had, so pods without any resource definition in that will be flagged. So this, you can see that a pod was created, but there was no resource definition, so it's been flagged by Kyverno itself. So let's say you have 1,000 of edge cluster you're creating, workload cluster, so you don't need to do it 1,000 times. You do it one time, and then it will be deployed to all your clusters that you have. So this is it. So with the help of K0rden, we are controlling the chaos of edge, so that with one platform, two platforms, so Kyverno and K0rden, we can actually deploy policies across your fleet. Thank you.
Any questions? We finished the session a little early, so any questions, guys? No?
All right. So if you have any questions or anything, please come and visit us to our booth.
And if you don't have any questions, visit, say hi. I would love to chat with you guys. So looking forward for it. Thank you for listening. Bye-bye.
Thanks.